Welcome to another fun-filled day of chemistry on the Journey Shade Chem. Please do the 2 warm-up questions to the best of your ability, and I will see you soon. The question in number 1 asks for us to make conversions. Now, it is extremely important that we get used to using conversion factors. And a conversion factor is where the value of the top number and the bottom number in the fraction are equal to each other. So a conversion factor is only changing the form of the number, not the number itself. In the first one, we had 46.5 micrograms. In 1 gram, there are 1 times 10 to the 6th micrograms. In 1 kilogram, there are 1 times 10 to the 3rd grams. 1,000,000 micrograms in a gram and 1,000 grams in a kilogram. Micros are used when we use micrometers in using microscopes. They are 1,000,000th of a meter. So I'm going to change this number to scientific notation so that I can just subtract and add exponents. I have 1 minus 6 is minus 5. Minus 3 is minus 8. So the answer is 4.65 times 10 to the minus 8th kilogram. For B, I'm changing millimeters to kilometers. So again, I'm going to go to my base unit. And there are 1,000 millimeters in a meter. There are 1,000 meters in a kilometer. So again, my number's in the bottom, so I'm dividing, and when it's exponential, I would subtract. 2 minus 3 is minus 1. Minus 3 is minus 4. So my answer is 7.26 times 10 to the minus 4th kilometer. Now, it's very important that you have the correct label with these because I need to know what I'm talking about here. So now we're in cubic units. When I have cubic units, I need to understand that there are 10 centimeters is 1 decimeter. And I am cubing the whole thing because when we use volume like gases where they have height, width, and depth, I have to use a cubic unit. So when I cube 10, I get 1,000 centimeters cubed, and 1 cubed is 1. So this is my conversion factor. So I have 1,000 centimeters cubed is equal to 1 decimeter cubed. Now the exponent is in the numerator, and this is 2.2 times 10 to the 1, so I have 1 plus 3 is 4, and so my answer is 2.2 times 10 to the 4th centimeters cubed. Cubic units is a little something new today, and it is also on the frog worksheet, worksheet B, and you can look at the expressions there for the conversion factors. In D, I'm changing kilometers to nanometers. So there are 1,000 meters in a kilometer, 1 billion nanometers in a meter. So because I'm multiplying, I'm going to add my exponents. Minus 12 plus 3 is minus 9. Plus 9 is 0. So the answer is actually 2.58 nanometers. I could put times 10 to the 0, but that's not necessary. Scientific notation is primarily for very large and very small numbers, so it's not necessary here, but if you did that, that would be fine too. Now, liters to milliliters, there's 1,000 milliliters in 1 liter. Again, our conversion factor must equal 1. And so this number would be 1,500 milliliters, or 1.5 times 10 to the 3rd milliliters. It's important that however many significant digits I begin with, my converted number must have the same number of significant digits. The last one, I'm going in the opposite direction of what I did in C. In C, I was going from decimeters cubed to centimeters cubed. Now I'm going from centimeters cubed to decimeters cubed. And remember, what I'm looking for should be in the top, and what I want to cancel in the bottom. So this number is 2.2 times 10 to the 1. This is 1 times 10 to the 3. And 1 minus 3 is minus 2. So my answer is 2.2 times 10 to the minus 2 decimeters cubed. Now, conversion factors can be very confusing in the beginning, but we'll practice them on numerous occasions so you'll get more comfortable with them. So I'm sure you might see them tomorrow on the warm-up as well. So right now, I would like for you to get out a calculator, because for number 2, we need to learn how to use our calculator. And you need to find your exponent button on the calculator. Some calculators say EXP, some say EE, some the EE is above another number and it's color coded. So if it has a color of yellow, that means you have to push the yellow button before you push the EE to get to that function. Sometimes it's a blue button, so you have to press the blue button before you press that blue EE. And when you do that, you never put in times 10 because the times 10 is taken care of by your calculator. Number 2, I will come back to you, and so you go get your calculator and we'll do it together. There are 2 rules you need to be aware of. The first is that when you're multiplying and dividing, you must first solve the problem, and then the final answer will be expressed to the least number of significant digits as given in the problem. So you solve it as you would normally, and then you look back at the original problem and count what are the least number of significant digits, and that's how you express your answer. When you're adding and subtracting, it's a different rule. And you look at the numbers in the problem, and the one with the least number of decimal places is how you express your final answer. So you always solve the problem as you would normally, but it's the final answer that then is changed because of the significant digit rules. So let's go back to the warm-up question. In your calculator, you need to press 1.25. Then you press the exponent button, whether it's EXP or EE. You do not do times 10 because when you press the EE button, that takes care of it for you. So you have 1.25 exponent 3 times 5.2 exponent. Now this exponent, you need to make sure that you do not use minus as you're subtracting and adding, but a negative. There should be a button that has a plus and a minus sign, or just a minus sign. So you make it a -8. And then you press equals, because your calculator has an order of operation. And if you don't tell it exactly the order that you want it to work, it will change it, and so you may get an incorrect answer. Then you press equals after you multiply these 2 numbers, and then you put in 2.5 exponent minus 5. And you come up with 2.6. Now it came out to be a whole number of 2.6. When I look back at my numbers, I see that this number has 3 significant digits. This number has 3 significant digits. And this number has 2 significant digits. So my answer should have 2 significant digits, which is how this one worked out on the calculator. However, if I had had 3 significant digits here, I would have had to put a 0 on the end of this number to give 3 significant digits. But because the least number of significant digits in this problem was 2, I can just leave my answer as 2.6. Now in B, we take 4.65 exponent 20 times 2.25 exponent -9 equals, divided by 8.55 exponent 8. And you should come out with a number of 1223.6842. And what we do, remember, is we cut it off after the 4th digit. after the decimal. And I look back at my original problem. There are 3 significant digits here, 3 significant digits here, and 3 significant digits. So the least number is 3. So I must express this number with 3 significant digits. So I look at the 4th digit to determine what the 3rd digit should be. And it's not a 5 or above, so I'm not rounding it up. So my answer will be 1220 for 3 significant digits. Now, when I'm adding and subtracting, there is a different rule. I use that my answer should only have the number of decimal places for the number that has the least number of decimal places. Well, when I add this number up, I get 105.1392, but the least number of decimal places given in this problem is no decimal places. So my number in the answer should not have any decimal places. So it would be 105. Now, if this number of 0.1 was 0.5, then this would become 106, because the least number of decimal places was no decimal places. For D, it's just straight multiplication, 2.55 exponent 6 times 2.8 exponent negative 3 equals 7140. And this number has 3 significant digits. This number has 2 significant digits, so my answer should only have 2 significant digits. I look at the 3rd place to determine what the 2nd place will be, and so my answer is 7100. So we have learned today how to use significant digits in our mathematical calculations. And from now on, I'll expect that you know that. So we'll follow significant digit rules for the rest of the year. And we'll always go back to the original problem and express our answer with the least number of significant digits given in that problem. So that was some fun today. I kind of like that math stuff, but we'll keep going and we'll learn density tomorrow. So can't wait to see you. Bye. See you tomorrow.